All right, so let's look at problem 10. All right, so 10 puts me some situation where I have a maximum for f of x is equal to 5, and I have a minimum when f of x is equal to -7. And the only other thing I know is that f is continuous, right? So this means that somewhere on my graph, this thing tops out at 5 and bottoms out at -7, and it's continuous. Okay, now, can I concoct a situation that would make the first one false? And I can. It's not hard to do. If I make my graph hit its maximum at 5 on the left-hand side of the y-axis, and then I'm gonna have it come like over here and go down to like the 7 and then come back up, and right, it's gonna stay in between those two places for the rest of it. So there's my maximum, there's my minimum, and it just stays in between for the rest of the graph. So let's take a look at what happens with f of the absolute value of x here. F of x clearly has a maximum of 5, a minimum at -7. F at the absolute value of x, though, is going to have an issue. Because, see, no matter what value I'm going to put in here, the absolute value of x is always greater than or equal to 0. Which means that f of the absolute value of x is always going to be somewhere on the curve over here. Because if the thing inside is always greater than or equal to 0, that's this part, right? The f part is going to be this part of the curve over here on this side of things. Well, its maximum looks like it's like here, which is definitely some value that's less than 5. So the maximum value here never actually gets to 5. So 1 doesn't have to be true. All right, so let's look at number 2. Number 2, okay, so same restriction, maximum's at 5, minimum's at -7. Okay, no matter what I do here, right, so here's my x and y axis, right? If the original function goes down to 7 at some point, up to 5 at another, and then kind of stays wherever in between, when I take the absolute value here of f of x, this part, right, the part below the x-axis, so let's get a little color to this. This part, the part below the x-axis, right? So this is the x-axis here, this is the y-axis. Now, when I take its absolute value, is above the x-axis. And how far can above the x-axis it get? It can get to 7. So if it hits -7 somewhere for some x, right? So let's say f of a, let's call this a. If f of a is where I hit -7, then the absolute value of the f of a has to get to 7. And it's never going to get any higher because above the x-axis it never goes above 5, and below the x-axis it never goes below -7. So 2 works. All right, so let's talk about 3. The minimum value of this thing has to be 0. Well, do we buy that? Well, I don't think so. Because that first graph, actually, I'll draw it again. That first graph where I had like, this is the y-axis, this is the x-axis, right? So this is y, this is x. That first graph where I had it kind of like go up to 5 over here, and then down to -7 up here, and then like stay in between for the rest of the path. This is -7 and this is 5. Right, the minimum value has to be 0. Well, no, because like I can take, let's say this is 1/2, right? Right. Oh, minimum value has to be 0. So not that one. That's not what I want to grab. Oops, I'm moving stuff around. That's not good. Let's, instead of talk about 1/2, let's talk about here, right? Here, let's make that like 5. I don't know. So f of 5 has to be -7. Oh, okay. So f of the absolute value of 5 is f of 5, which is still -7, and -7 is less than 0. So the minimum value here is definitely not 0 in that case. So we disproved 3. So we disproved 1, we disproved 3, we made an argument in favor of 2, so I'm going with answer B. Just 2. All right, I hope this is helpful. You're probably seeing this in your morning, because it's your morning right now, so you probably see this in about an hour or so. All right, awesome.